everyone, and welcome back for another deep dive. Today, we're going to be diving into the world of the Internet computer. And before anyone runs away thinking this is just for the techies out there, trust me, this is about the future of the entire Internet, which, well, affects all of us, right?
Absolutely.
So, to navigate this, we're using the Internet Computer Whitepaper version 1.3 as our guide. Our mission today is, well, threefold. First, we'll break down what this technology actually is. Then we'll explore how it's different from everything else out there, how it pulls that off. And by the end of this, you'll understand why this matters way beyond just lines of code. Like, for example, have you ever heard of a blockchain that doesn't force you to download its entire history just for you to use it?
It's a common misconception, actually.
Yeah, well, the IC is doing exactly that. And we'll uncover how they do it a little bit later in this episode. But before we get too far ahead of ourselves, let's start with the foundation of all of this. Smart contracts. Now, I know what you're thinking. Here we go with the jargon.
It does get thrown around a lot.
Right. But stick with me here. Imagine a vending machine, right? You put in your money, you make your selection, and boom, your snack is dispensed. Simple, right? Well, that's essentially a really, really simple, smart contract in action.
Exactly. It's an agreement written in code. And just like that vending machine, it automatically executes when the right conditions are met. But the real magic, the really exciting stuff happens when we scale this concept up. I mean, we're not just talking about dispensing snacks here, right? We're talking about automating really complex transactions, agreements, even entire organizations, all without the need for a middleman.
Okay, I'm with you so far. But why is this such a big deal? What's the advantage of having these digital vending machines running our code?
It all comes down to trust, or rather the lack of it. See, with traditional systems, you're always relying on some intermediary, right? Whether that's a bank, a lawyer, a tech company, someone to act honestly and actually uphold their end of the bargain. But with smart contracts, that trust is literally built into the code itself. It has to execute exactly as it was programmed, without bias, without that potential for interference.
So it's like having a digital contract that simply cannot be broken. That's a powerful concept.
Exactly. This trustless execution is what makes Web3 so compelling. It gives us the potential for a future where users have more control over their own data, over their digital lives. It's about creating applications that are truly open, transparent, and equitable.
It all sounds incredible in theory, but there must be a reason why we haven't all switched over to this Web3 utopia yet. What's the catch?
Well, the thing is, traditional blockchains, for all they did to revolutionize things, weren't really built for this vision, at least not at the level we're talking about.
Interesting.
Right. They can be slow, expensive to use, and, to be honest, they struggle to handle the sheer complexity of the really sophisticated applications that we're talking about. And that's where the Internet computer comes in. It offers a totally new paradigm to actually overcome those limitations.
All right, so we've got the amazing potential of Web3, but we've also hit our first roadblock. This is where the Internet computer steps onto the scene, promising us a way forward. But how does it actually deliver on that promise? That's what we'll uncover in the next part of our deep dive. We'll explore the ingenious architecture that makes the Internet computer tick. Stay tuned. Welcome back. Last time, we left off with the Internet computer offering a solution to those limitations we were talking about with traditional blockchains. So how does it actually work? Where do we even begin to unpack something as ambitious as, well, reinventing the Internet?
Well, the Internet Computer White Paper lays out a really elegant architecture, actually.
Okay.
Yeah, it's built in layers.
Okay.
4, to be precise.
Okay.
And each one has a really specific role to play, kind of like a well-coordinated team all working towards a common goal.
Okay, I like that analogy. So what are these layers, and how do they all work together?
So at the very foundation, you have the peer-to-peer layer.
Right.
This one's all about making sure that all the computers in the network can talk to each other reliably and securely. It's like the bedrock of communication for the whole system.
Okay, that makes sense. Communication is key for any team.
Yeah,
Right.
exactly.
So what's next?
All right, so on top of that, you have the consensus layer. And this is where things get really interesting.
Ooh, I like where this is going.
Right. So with those traditional blockchains, actually reaching a consensus on the order of transactions,
Yeah.
that can be a really slow and resource-intensive process. But the Internet computer, this uses a totally novel consensus mechanism,
Okay.
and it's been designed for both speed and efficiency.
Hold on, so it's like it's finding a way for everyone to agree on the rules of the game
Exactly.
without these endless debates and bottlenecks.
Precisely.
That sounds absolutely crucial for actually maintaining order in this decentralized world. But how do you even prevent someone from, like, trying to cheat the system or manipulate it?
Ah, such a good question. The Internet Computer has a few tricks up its sleeve to handle that.
Okay, good.
For one, it uses something called Byzantine fault tolerance.
Byzantine fault tolerance.
Yeah, essentially what this means is that the system can actually tolerate a certain number of failures, even malicious actors,
Wow.
without compromising the integrity of the entire network as a whole.
That's impressive.
It's pretty wild.
But how does that even work? Walk me through it.
Okay, so imagine a network where some computers, right, might be giving out incorrect information, whether it's accidental or deliberate.
Right.
Byzantine fault tolerance makes sure that the system can still reach a correct consensus, even if some of those actors are actually compromised.
Wow.
And it achieves this through some really, really clever algorithms and redundancy, which ensures that there's no single point of failure that can bring down the entire network.
Okay, that's some seriously resilient engineering.
It is.
So we've got communication, we've got this agreement, even safeguards against the bad actors out there. What's the next layer in this internet revolution?
Next up, we have the message routing layer.
Message routing layer.
Think of it like a super hyper-efficient postal service.
All right.
It makes sure that messages are being delivered to the correct canisters.
And canisters are, remind me.
Canisters are the building blocks of applications on the Internet Computer.
Right. Yes, the canisters. It's all coming together now. So this layer basically ensures that all of those canisters can talk to each other.
Seamlessly,
Yeah.
securely. Yeah.
Got it.
And then finally,
Yes.
we reach the top layer, the execution layer.
Ooh, the execution layer.
This is where the magic actually happens. This is where the code of the canisters is executed, where transactions get processed, where this whole system comes to life.
So if we're sticking with your team analogy, this is where the team actually executes the plan, right?
Yes.
Putting all those carefully coordinated efforts into action. I love it. It sounds like the Internet Computer has really thought of everything.
Yeah.
But there's one thing we keep dancing around that I really want to unpack. This Chainkey cryptography. What is it, and why is it the secret sauce of the Internet Computer?
Chainkey cryptography is definitely one of the most fascinating aspects of all of this. It's a technology that sits underneath everything else, and it enables a lot of the platform's unique capabilities. And we'll dive into all of that right after this break.
All right, we're back, and I'm ready to unlock the secrets of this Chainkey cryptography. It sounds kind of mystical, like something straight out of sci-fi.
Well, it is pretty revolutionary when it comes to blockchain, that's for sure.
Okay.
Chainkey cryptography is really the engine under the hood of the Internet Computer. It's what makes this whole different approach to security and efficiency possible.
Right.
And at the heart of it all, a little something called threshold signatures.
Threshold signatures. All right, break that down for me. How do these things work, and why are they so important for all of this?
Okay, so imagine you have a safe.
Okay.
Inside, you've got this really vital piece of information. And naturally, you want to protect it with a key.
Of course. Yeah.
But instead of giving the entire key to just one person, what if you broke it into pieces?
Okay.
And then you gave those pieces to multiple people you trusted.
Oh, okay, I see where you're going with this.
Right. That's basically the idea behind threshold signatures.
So it's like a distributed key then?
Yeah.
Where you need a few people to cooperate to actually access the information.
Exactly. And I think you can see how that adds this whole extra layer of security, right?
Yeah.
For sure. Now, let's take it a step further. What makes threshold signatures really remarkable is that you can set a threshold.
A threshold, okay.
Meaning you get to decide how many of those key pieces
Yeah.
are actually required to unlock the safe.
Interesting.
So, for example, you could have 5 key pieces, right?
Yeah.
But you could decide, hey, any 3 of them are enough to actually reconstruct the full key.
Ah, so even if a couple of those pieces go missing or they get compromised somehow,
Exactly.
the information is still safe. That's brilliant.
Right.
But how does this all translate to the world of the Internet Computer?
So the Internet Computer, it uses these threshold signatures for a bunch of different things,
Okay.
all in the name of boosting security and trust.
Right.
For example, when the network needs to generate random numbers, which is essential for a lot of cryptographic operations, it doesn't rely on a single source.
Okay. Makes sense.
Instead, it has multiple nodes use these threshold signatures to contribute to the process.
Gotcha.
And that makes it pretty impossible for any single party to manipulate the outcome.
So it's kind of like a decentralized lottery.
Yeah, exactly.
Where everyone's contributing to picking the winning numbers.
Yeah, and that ensures fairness and unpredictability.
Love it. I'm starting to see how this chain key cryptography really weaves its way into every part of the internet computer.
Exactly. And honestly, it goes even deeper than that.
Okay, how so?
Well, they also use threshold signatures to verify transactions on the network. So instead of having one single authority validating each transaction, you have multiple nodes participating in the process,
Wow,
which makes it really, really hard for any fraudulent transactions to slip through.
that's incredible. This all sounds incredibly secure, but what about, the human element? We've talked about key pieces getting lost or even compromised. What if someone's intentionally trying to exploit the system?
Well, that's where another fascinating piece of chain key cryptography comes into play. Proactive resharing.
Proactive resharing, another buzzword to add to the list.
I know, right? But it's a good one. So remember earlier how we talked about dividing that key into pieces?
Yeah.
Well, now imagine if we could change those pieces periodically.
Oh, interesting.
Like create a whole new set of shares for that same key,
Yeah.
but without ever actually exposing the original key itself.
Okay, so even if someone manages to get their hands on a few pieces of the old key, it's like those locks have already been changed, right?
You got it.
Yeah.
Proactive resharing basically ensures that even if a few of those shares are compromised, the system is still secure because those old shares are useless.
That's brilliant. It's like this constantly evolving security system.
Right.
It makes the internet computer practically impenetrable.
Well, it's definitely designed to be.
I love it. And all of this complexity is going on behind the scenes, right? To support these canisters that we talked about earlier.
Exactly.
Remind us again, what are canisters and why should we even care about them?
So canisters are basically the building blocks of applications on the internet computer. Think of them like smart contracts, but on steroids.
Smart contracts on steroids. I like it.
Right. They can do so much more. They're these self-contained programs that can run any kind of code.
Yeah.
And the best part, they can all talk to each other seamlessly and securely across that entire network.
So canisters are like the apps on our phones,
Yeah.
but designed for a world that's actually decentralized.
That's a great way to put it.
Awesome.
And this is what's so exciting, right? This is the potential for this whole new ecosystem of applications that are controlled by no single company, that is.
Right.
They're tamper-proof, and they can interact with each other in ways that, honestly, we probably haven't even thought of yet.
This is where things get really, really interesting for me because we've talked about all these technical foundations, right? The security, these building blocks for this new internet. But who decides how this all works? Who governs the internet computer itself?
Well, that's where DAOs come in.
Ye-
Decentralized Autonomous Organization.
Right. DAOs, of course.
The internet computer actually governs itself using a DAO called the Network Nervous System, or NNS for short.
So the internet computer has its own, digital brain,
Pretty much.
and it's run by the users themselves.
Exactly.
That's a whole other level of decentralization.
Right. It's pretty amazing when you think about it. The NNS basically makes all the big decisions about the network.
Okay, like what? What kind of decisions?
We're talking about things like upgrading the protocol itself, managing the economics of the system, even deciding which computers are actually allowed to participate in running the entire network.
Wow.
And it's all done through proposals and voting. So token holders have a direct say in how the internet computer evolves.
This is incredible. We're talking about a platform that's not only super secure, crazy efficient, and capable of running these next-gen applications, but it's also governed by the community itself. This is mind-blowing.
That's the dream.
Right.
It really is.
And it's what makes the internet computer so compelling. It's this glimpse into a future where the power of the internet isn't just held in the hands of a few,
Right.
where users actually have real control,
Yes.
and where we can have all this amazing innovation, but without the limitations of those old centralized systems. I love it. Well, this has been an incredible deep dive. We started with the very basics of smart contracts, and we explored this intricate chain key cryptography, this really ingenious architecture, and we even talked about the power of canisters and DAOs. It's safe to say that the internet computer is pushing the boundaries of what we even thought was possible with technology, and honestly, I'm really excited to see how all of this reshapes the internet as we know it. If you're as intrigued as I am and you want to learn more, I highly recommend checking out the full Internet Computer white paper. Yeah, it's a bit of a dense read, but it'll give you an even deeper appreciation for the absolute revolution that's brewing in the tech world. Until next time, keep exploring, keep learning, and as always, stay curious.